So today we're continuing with our graphing. Yesterday we graphed the sine function, the snake-shaped graph, and today we're doing the cosine graph. Okay, so we're going to do the same thing. We're going to start off with the t-chart. This is x, and I'm going to put right here that we're going to graph y.
Is that this u?
Yes. Y equals cosine x. So x, and instead of y, what would I put here in the y spot? Cosine x. And I'm going to use the same key points that I did yesterday. Do you guys remember what they were going around the unit circle?
Pi over 2.
0. Pi over 2. 3 pi over 2 and 2 pi. 1, 2, 3, 4, 5. Okay, so think of the quadrantals that we had yesterday. They look like this. This is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Cosine are the x values or the y values of your unit circle. The x, so we're going along the unit circle and picking up all of our x values. So what do I put here for the 0? 1, because the x value is 1 and cosine is what we are graphing. Pi over 2, what's the x value? 0. Pi, negative 1. 3 pi over 2, 0. And 2 pi, 1. Okay, so remember the one we had yesterday was 0, 1, 0, negative 1, 0. How many zeros did we have here? 3. How many zeros do I have here? 2. With how many maximums? 2. And how many minimums? 1. Do you guys see that? Yes. Where with the sine graph, how many maximums did we have? 1. And how many minimums? 1 and 3 zeros. Okay, and again, that's over one period. If you graphed more periods, there would be more maximums and more minimums. All right, so let's go ahead and get our graph set up. One, negative 1, and you do have to label that. 2 pi, and then I try to get you guys used to cutting things in half, because when we do shifting and the periods change, it's good if you know how to do this cutting in half and finding the patterns. What's 2 pi cut in half? Pi. What's pi cut in half? And yes, we know this is 3 pi over 2, but you should still count just to get used to it. 1 over 2, 2 over 2, this would be 3 pi over 2, and then 4 over 2 is your double checker. 1, 2, 3, 4 over 2, is that equal 2 pi? Okay. Alrighty, so then we plot 0 is 1, pi over 2 is 0, pi is negative 1, 3 pi over 2 is 0, and 2 pi is 1. Okay, so remember, you don't want pointy pieces, you want them all smooth. So think right in here you're doing half of a hill, like a little hill shape, and then connect that into a valley, and then connect that valley into another half a hill. Half a hill, a valley, half a hill. And make it all smooth and connect the best you can. Okay, questions? All right, so sine graph, like an S shape or a snake shape. The cosine graph, you can think of it as a C shape, a cup shape, however you want to think of it, but remember your 5 key points: maximum, 0, minimum, 0, maximum. 2 maximums, 1 minimum, 2 zeros. Of course, unless it is flipped around, which we will see in just a second. What's the amplitude here? We talked about that yesterday. The amplitude is 1. It's the absolute value of the coefficient. Or the definition we had yesterday was it's half the length or the distance between your max and your min. What's the distance between 1 and -1? 2, and 2 cut in half is 1. All right, questions on this one? We're good? Okay. Number 2, we're going to go straight to trying to graph without the T-chart.
Isn't it called the directrix? No.
For what?
What at the bottom of that thing? What's the directrix again?
Different shape.
Oh, okay.
Yeah. Focus and directrix for parabolas.
Oh, that's parabola. Okay.
Yeah. Yeah. Oh, you're like the star and then the line.
Yeah.
Yeah. That's for parabolas. Okay. Number 2. Y equals -2 cosine x. Okay. So let's see if we can get this without a T-chart. What is the amplitude? Positive 2, because the amplitude is always positive, absolute value. Okay. So the negative doesn't impact the amplitude, but what does it change in the graph?
It inverses the graph.
It flips it around?
Yeah.
Yeah? Okay. So don't forget to label your amp, like your 2 and -2. Okay, and then you have your 2 pi cut in half, cut in half. Okay, so what's 2 pi cut in half? Pi cut in half. And 1/2, 2/2, this would be 3/2. And I know you guys are saying, I already know all these. Why do we have to think of it that way? Believe me, when we move on, it's going to be helpful to know that. All right. Now, because it's negative, it's going to flip this around. So will I start at my maximum or my minimum? Minimum. Still go to a 0. So I went max 0 min. For this one, I'm going minimum 0, then a what? Maximum back to a 0, and then down to a minimum. So now you have half a valley. Think of a hill here, and then half a valley, and try to get it as curvy as you can. All right, so in this graph, we still have 2 zeros just like this one. What's changed? Instead of 2 maximums, we have 2 minimums, and how many maximums? 1. 2 maxes, 1 min, 2 minimums, 1 max. Do you guys see how that changed? Okay, so remember, if you can remember the sine graphs, 0 max, 0 min, 0. And your cosine graphs, maximum 0, minimum 0, max. Again, flipped around if there's a negative. Got it? Questions? Okay. We're going to write down some stuff about amplitude and period. Y equals a cosine of bx. Y equals a cosine of bx. Got it? Okay. A tells us what?
Amplitude.
Amplitude. Amplitude is A or absolute value of A?
Absolute.
And why do we put absolute value with the chance that A might be negative? Because it is a variable, it could be negative. And if I just put A, that would be wrong, because if A is negative, I'm saying amplitude is negative, and it cannot be. Does the absolute value hurt anything if my A is positive? No, because the absolute value of a positive is still positive. It's not taking the opposite. All right, does anybody remember what the B tells you from last year? You're a step ahead of me. You're a day ahead of me. It's okay. We are going to get there. It tells us the period length. Did you guys do that? Like changing the period length, or did you always use 2 pi?
Always use 2 pi.
Okay, so this part is new. Your period is 2 pi over b. But the shifting right and left, we will get to that one. Okay, 2 pi over b. Now, let's take a look at the ones we've been doing. What is the coefficient of x right here on this problem?
1.
1. Do you see that? And what's 2 pi over 1? So that's why this period was 2 pi. And I put cosine here, but the same is true for the sine function. So here, what's the coefficient of x? 1 and 2 pi over 1? 2 pi. Is that the case on all of these? And again, why the period was always 2 pi. Same thing with the ones we did here at the end. Coefficient of x is 1, coefficient of x is 1, 2 pi, 2 pi. Okay, do you see that? So it is going to change. Coefficient of x is 1, 1, 2 pi, 2 pi. All right. Questions before we try one? Yes. Yes. Let me do one here. Like, let me explain what the problem so I can explain a little more what it is. All right, we're going to graph number 1, y equals cosine of 2x. Okay, so that's changed. We haven't seen one, and from what you guys are telling me, you did not do this last year either. So this is new for us. So we will list our amplitude. What is our amplitude? 1. The coefficient here is 1. Period is always going to be 2 pi over your coefficient of x. So for this problem, what is it going to be? 2 pi over 2. So what is my period reduced to? Pi. What that means is I am going to hit my max, my 0, my minimum, my 0, and my max, all those 5 key points by the time I get to pi. So it's all going to get squished in here like that. Can you guys imagine that? Yes, like that. It's going to get squished in and all get done by the time I get to pi. Make sense?
Yeah.
Okay. Questions? Okay. Now, technically, because you're making your own graph paper, you could put pi out here if you wanted, but just so I can compare, I'm going to try to keep it somewhat the same. So I'm going to put pi here, but typically when I graph from now on, I will stretch it out more just so that I have room to graph, because when you put in a tight space, it's really hard to get all your pieces labeled. Okay, so typically I will spread it out more, but I want to at least somewhat compare here. Okay, so remember what we talked about cutting in half. What's pi cut in half? Pi over 2. What's pi over 2 cut in half? And then I talked about looking for that pattern. This is 1 over 4. This would be 2 over 4. This would be 3 pi over 4. And then you double check it. 4 over 4, would that be 1 pi? Yes or no? Okay, so that last one is always your double checker. So this is what I was telling you guys about cutting in half. And you can see why I typically don't squish it in this small, because it's really hard to see. So typically I will be stretching it out more. But pi cut in half is pi over 2. Pi over 2 cut in half is 1/4. So you say 1/4, 2/4, 3/4, and 4/4 does reduce to 1. Do you guys see how we did that? Okay, so that pattern I was telling you to look for earlier, we're now using. Okay, it's positive, so it's going to be maximum, 0, minimum, 0, maximum. Do you guys see how I got that? I just followed this graph up here. Max, 0, min, 0, max. Followed that same thing with these 5 key points instead. Maximum 0, minimum 0, max. And you do half your hill, your valley, and half your hill. So do you see it's exactly the same, it just squished it in so it starts and ends in a smaller period. Make sense? You could also stretch it out to like start and end over 4 pi. I mean, there's a number of things, different things that can happen. Questions on any one of these? Does that answer your question, kind of? Okay, we will get more practice. Okay, number 2. y equals negative 5/2 cosine pi over 2 x. You ready? The other side?
Yeah.
All right. What is the amplitude? 5/2. Period is 2 pi over b being the coefficient of x, 2 pi over what? Pi over 2. Need you guys paying attention. How do we work that out? That becomes 2 pi times what? 2 over pi. What ends up reducing here? Pi. That doesn't always happen, but sometimes it does. So your period is what? 4. All right, amp is 5 over 2. Period is 4. Any questions? Okay. Let's graph. Now, like I said yesterday, if you want to mark all the, 1, 1.5, 2, 2.5, you can, or you can just put 5/2. What is 5/2 as a decimal? Okay, so as long as you label, I'm okay. If you want to get a little more accurate and show 1, 1.5, 2, 2.5, and so forth. All right. So I'm going to put 4 out here. Why 4? Because that is my period. Whatever my period is will be my end point until I start shifting. So the period here was 2 pi, I ended at 2 pi. Period here is 2 pi, I ended at 2 pi. The period here was what? Pi, so I ended at pi. Does that make sense? So if my period is 4, I'm going to end at 4, and I do all that cutting in half business. What's 4 cut in half? 2. What's 2 cut in half? 1, and that pattern's pretty easy to see. It's 1, 2, 3, 4. 5 key points. There's only 4 here. Where's the 5th key point? 0. Okay. Cosine, it's negative, so is it going to start at the maximum or start at the minimum? Minimum. And the minimum being negative 5/2. What's the next key point? 0. Minimum 0, maximum. Next key point? 0, and the last key point? Minimum. Good job. So you have half your valley, your hill, and then half your valley. Got it? Questions? All right, what about this one? Y equals 2 sine of 4x. All right, we ready? Amp. What's the amp? 2. Period. 2 pi over 2 or 2 pi over 4? 2 pi over 4. Now, does the pi reduce on this one? No. Does the 2/4 reduce? Yes. 1 and 2. So what is the period? Pi over 2. Okay. Now, I'm really going to have to spread this one out because that means I'm going to start and end all before I get to pi over 2. That's really squished. Can you see that? Yep. So I'm going to hit my max, my 0, my minimum, my 0, my max, all of that before getting to pi over 2. And that's going to be way too hard for me to squish all those points in there, so I am going to spread it out a little bit more. Okay. pi over 2. You know what, I'm going to spread it out just a smidge bit more. So is this drawn to scale with the other graphs that I did on the other page? No, because if I were to do that, my pi over 2 would be like right here. And that's going to be really hard to cut, and cut. So I'm going to put pi over 2 here. And we do the same thing. What's pi over 2 cut in half? Pi over 4. What's pi over 4 cut in half? That's 1/4 times 1/2. Pi over 8, and we look for the pattern. This is 1/8. This is 2/8. This would be 3/8, and this would be 4/8. And I'm just going to double check. Does 4 over 8 reduce to 1 over 2? Yes. Does 2 over 8 reduce to 1 over 4? So did the pattern work? So like I said earlier, you want to get used to doing that. 1/8, 2/8, 3/8, 4/8. Okay. Questions? Is this positive or negative? Positive. So we're going to start at our minimum or our maximum. Or neither. Neither. Good job. Why not? It's a sign, and sign always starts at 0. Good job. Okay, so I'm going to quickly come back to my sign graph. 0 max, 0 min, 0. And if it was negative, 0 min, 0 max, 0. So since it's positive, we're going this way, yes? Okay. So 0 max would be where? 2, 0, minimum 0. So you make your hill and then your valley. Okay, got it? Any questions? Do another one, or do you have the hang of it? Good?